Welcome to the UGC EPG Pathshala lecture series in computer science. In this series of lectures, we have been looking at the subject database management system. For the past few sessions, we have been discussing on data mining, its techniques. Last session, we have started doing on one of the technique called association rule mining technique. And this session will be talking more on the classification and its techniques, and we will continue that with clustering techniques. So, these three are very important techniques as part of data mining. So, in this particular session, we will be addressing more towards classification in data mining, and the learning objectives for this session include: initially we will tend to understand the difference between classification and prediction. Then we will present some of the issues regarding classification, and we will talk more on the classification techniques. For this session and this particular lecture, I will be discussing on decision tree induction technique and to detail in large on the different data mining tasks. First, let us try to understand what is classification. So, by way of definition or defining what a classification means, classification is nothing but given a collection of records which we term it as training sets. So, given a collection of training sets where each record contains a set of attributes. So, this is supposed to be in format of a relation or a table which will have a list of attributes, and one of the attribute is termed as a class. See, the predicted value that we might expect or the decision with which we wanted a certain output, we call them as a class, and a list of other records that are associated with this table, we mean it as attributes, and the entire collection of records we call it as training set. Classification generally goes by supervised learning methodology, where we will have a group of items or a collection of records which are initially to be trained, and subsequent information can be tested, used for the purpose of testing. So, this is how we tend to define classification is nothing but given a collection of records which we term it as training sets, where each record contains a set of attributes and one of its attribute is termed to be as a class. With a training set, the intention is to create a model for a class attribute as a function of value of other attributes. Considering a group of other attributes, we may have to create a model which should say the actual output that might be desired based out of the given list of attributes. The primary goal with which we start working on this classification is this particular value should be previously unseen. So, previously unseen records should be assigned a class as accurately as possible. So, as I have mentioned, class is the important attribute that we are looking out for, and to derive a class attribute, we may have to look at certain previously unseen records by way of testing, but there are certain training values which are already existing. Based upon those training values, these predicted values are to be derived, but that should have been not existing on the previous class. And we are looking out for more of accuracy, because it is predicted, we are looking out for more accuracy in terms of classification. So, that is one component relating to the training set. Likewise, there is also another set which is called a test set. As I have already told you, previously unseen records, we might either use it for classification, and similarly a group of attributes which can be fed to derive the actual result for the class attribute, we may term it as a test set. So, a test set is used to determine the accuracy of the model. So, for classification, the measure of accuracy plays an important role. By giving a list of attributes, we may have to understand clearly what would be the class that these group of or this list of attributes would derive with. So, usually the given data is divided into training and test sets. With training set, we try to build the model, and with the test set we usually go for validation of the model. So, any model that has been defined initially, we may have to validate that by use of the test values. As we have seen in the objective, we will try discriminating between these two words, classification and prediction. Majorly, when we talked about the definition of data mining looks after previously unseen trivial data values, which is better for prediction purposes. So, how is this derivation of class compared with prediction? Basically, classification looks after predicting categorical class labels. Let us see what categorical class labels mean. Classification looks after prediction of categorical class labels, that is any one of the category mentioned. Say for example, if it is a gender, it could be either male or female. So, if I have a category on that which mentions a group of items which are belonging to male and a group of members who belong to female category, then these becomes the categorical data and we can predict on this particular data. Likewise, the other group which classifies data based on training set, thereby we construct a model and the values in classifying attribute and uses it in the classifying new data, whereby we create a new class label. Whereas, prediction models use continued valued functions, that is it predicts unknown or missing values. Some of the very typical classification applications that we see is for credit card approval. Having taken the PIN number, or we will try inserting whether it is a saving account or a credit account, then we will insert the card number, and finally after verification of the PIN number it approves. So, credit card approval, target marketing group or concentrating on a specific target, how to approach them, how to classify them would be the sole purpose. Medical diagnosis system. So, looking after the WBC and RBC values, we cannot infer saying that this person would have such and such diagnosis. So, instead we may have to take so many tests which can make us help diagnose the system. So, every test becomes one of the attribute and the final class label needs the diagnosis, and treatment of effective data analysis would be part of this classification. So, majorly for applications such as medical healthcare records, medical diagnosis systems, we might prefer classification techniques. So, looking at the process of classification, classification is a twofold process. In step 1, we will try constructing on the model, and step 2 we try using the model. So, model construction basically refers to creation of a training set where, as per the PDCA principle, which is plan, do, check and act principle, we might have to flow through a list of few possible processes, thereby we can construct a model. So, this model construction describes a set of predetermined classes. Each tuple or a sample, or otherwise it may termed as a sample, is assumed to belong to a predefined class as determined by the class label attribute. So, the set of tuples used for model construction, we name it as training set. This we have already seen. The model is represented as classification rules or decision trees or a mathematical formulae. And after having created this model, we might have to use the model now for classifying future or unknown objects, whereby we estimate the accuracy of the model. For a given test set, if the class label is found to be as accurate as possible with the desired result, then we say it is more accurate for the given list of class values. So, the known label of test sample is compared with the classified result from the model, and depending on the accuracy rate, which is seeming to be the percentage of test samples that are correctly classified by the model. So, how many of the values of the test set are identified to be correct in connection with the previous existing training values, that determines on the accuracy of the classification process. Test set is independent of training set, or otherwise we will call it as overfitting will occur. Overfitting is on top of what has happened or the problematic situations which we will see. So, this is a simple model where we learn and try to apply it for the test set. So, any learning algorithm having given us input, we will try producing a list of attributes or a group of attributes, like the initial attribute is transaction ID, attribute 1, attribute 2, attribute 3, and finally what is to be checked is mentioned as a class label. And each and every group, say each and every record, or this is a collection of records which are unique by its terms, maybe it might differ from say attribute 1. Attribute 1 majorly depends on two values which are yes and no. Attribute 2 depends majorly on three different categorical labels which are large, medium and small, and attribute 3 is completely a continuous value, whereas class label should be a categorical again, whether it should represent yes or no. So, we will try giving in all the possible combinations as input, thereby we will initially, these are assumed to be as training samples, this will be considered for learning the model. So, by looking after the learning algorithm and the group of attributes from the table, we will create a learning model. After successful creation of a model, now that we may have to apply it on the test set. So, we deduce by giving another group of items, it is not from the same group, another group of records or collection of records, how it identifies the different class labels is the actual quantum of classification task. Now that we will see some of the examples of this classification task, people might ask, is there any possibility of predicting tumor cells as benign or malignant? So, this becomes a categorical data. I have only two classes defined, one is benign and the other one is malignant tumors. So, to identify this particular or to predict this particular tumor, we create a categorical data from where we apply this categorical data into a classification technique. There is another classification which might help us doing credit card transactions. What are the group of customers who will be helpful by providing them with a credit card, how much they spend, all these can be easily studied. So, credit card transactions as whether they are valid or fraudulent transactions can also be preferred, or you can even start with classifying the customers as say platinum customer, gold customer, silver customer can also be identified, and whether the transaction that has happened is a legitimate transaction or a fraudulent transaction can also be studied. And classifying secondary structures of proteins as alpha helix, beta sheet or random coil is also a part of the biomolecular study of classification. And categorizing news stories such as finance, weather, entertainment, sports might also be one of the classification tasks. So, as we have seen, the model for construction of a classification is very common by giving a group of records as an input or indection, and we may after creation of a model we may have to create or we may have to check out for the accuracy by giving a test value. So, that is a generic model that has been created over different techniques. So, classification techniques vary with decision tree based methods, rule based methods, memory based reasoning methods, neural networks, naive Bayesian and Bayesian belief networks, support vector machines. So, these are the different groups of classification techniques that are available for use, of which in this particular session we will try understanding, or for the better understanding of classification we will try studying on the decision tree induction algorithm and the technique. If you look at decision tree algorithm, it is a flow chart like tree structure where the internal node denotes a test on an attribute, the branches represent an outcome of the test, and the leaf node represent the class label or class distribution. So, looking at the entire flow of this tree structure, anything which is to be given as input, we call them as an attribute, that is a test of an attribute. The branch represents the outcome of the test and leaf node represent the class labels or class distribution. So, decision tree generation actually have got two phases, one is tree construction phase, the other one is tree pruning phase. As part of tree construction, we have at the start all the training samples are to be considered as root. So, partition examples recursively based on selected attributes. So, it is in turn dependent on a group of attributes which are listed in the table. Every attribute might be considered as the root of this tree. So, it is actually to happen on a repetitive fashion. On a recursive list of or group of selected attributes, we may have to partition based upon different tree construction. So, after having constructed the tree, we might have to prune the data where we try identifying and removing branches that reflect noise or outliers. So, the algorithm goes in this format. The basic algorithm of decision tree induction is a greedy algorithm where the tree is constructed in a top down recursive divide and conquer manner. When we start, all the training examples are considered to be the root. Attributes are categorical. Majorly attributes are categorical. If it is continuous valued, they are discretized well in advance. So, they are either grouped, say salary is one of the, salary can never be a categorical attribute, but then this has to be made discretized, saying that between this and this range it is one category. Examples are partitioned recursively based on selected attributes, and test attributes are selected based on a heuristic or statistical measure, which is primarily based on the information gain, that is the entropy value of the given attribute. So, when do we stop on the partitioning? So, certain conditions are listed for stopping on the partitioning. All samples for the given node belong to the same class. There are no remaining attributes for further partitioning. So, it has to consider all the attributes that are listed in the table for itself to construct it as a tree. So, majority voting is employed for classifying the leaf. There are no samples left. So, till there are no samples left, we may have to continue doing recursively on the construction of tree. So, this is one specific example of decision tree based classification, where we have 5 attributes associated, but then the first attribute is unique, which is a transaction ID. Starting from the second attribute, if we start categorizing or if we start constructing the tree based on refund attribute, we can construct the entire tree structure. Likewise, marital status, taxable income could be different attributes which can be considered for construction of a tree. Refund is supposed to be a categorical attribute, primarily because refund we expect the answer to be either in form of yes or no. Marital status is again a categorical attribute where it is either single or married, whereas taxable income, the entire value is independent of any specific category. So, it is a continuous attribute, of which the class label identified is to find whether this person is trying to cheat based upon this relation. So, if we start dividing the attribute labels, then this becomes the initial attribute marital status. Then I look for a value called single or divorced, yes or no. On S, I have a group of people who have a refund. Again, it classifies into yes or no. Again, I am checking for the third attribute, which is taxable income, which takes in a category of less than 80k and more than 80k. If all the values are found to be yes, then this actually fits in for the classification principle. So, there could be more than one tree that fits the same data. So, as I have already told you, this condition is being applied to individual attributes. Say taxable, I can start constructing taxable income as the root of the tree, marital status as a root of a tree, and refund as a root of a tree. Likewise, I can construct 3 different trees, recursively it will be processed, and the best out of which is being identified for further processing. Let us look at splitting the attributes by constructing refund in the beginning, and marital status is being given as the second attribute for it to get executed. So, this is another classification which is done basically looking at refund as the root node. So, having classified this attribute, so all 3 attributes are constructed individually as trees. Now that we may have to apply it to the test set. So, we are at the applying phase, or we are at the test phase now. So, we may have to apply it to the model. The model is now created. This model primarily gains importance from the information gain values, that is purely on entropy values, and these entropy value clearly distinguishes itself from other classes of data. So, now looking at the start of the tree, any value that is applied, say for example, the attribute that is to be tested has its values like refund status is no, marital status is married, and taxable income is exactly 80k. The class label is to be identified, is to be understood or predicted. So, to identify the class label, we apply it to a tree wherein we have constructed a tree with refund as a root node, since this delivers the highest possible information gain. So, having given this as an input to this particular tree structure, we might be able to derive whether it is yes or no. So, initially it tends to identify from the test data whether the refund status is yes or no. Having given no, then it marches it to the marital status and sees that whether the person is single or divorced or it is married. So, by looking at this particular value, it can go to this leaf node where it will check for the taxable income, or having said married, it can directly say a value, because our training samples did not carry any value for a married person. So, married person where the taxable income is not exist. So, it can directly conclude with an answer of whether cheat with an answer of yes or no, the answer is clearly saying no. So, in case if the person is single, if that is the value that is mentioned, then the taxable income is to be checked, and we will go for identifying whether the person is a cheat or not. So, this is the entire procedure of classification, where we initially tried understanding on the training samples, whereby we have created a model using an algorithm, and we tested this with the same model to identify how accurate our test values are. So, as I have started with saying in this particular session, the entire phase of classification is a supervised learning, since we had a training set, and there are a list of items which we tested further. So, after having done a training phase, we do produce supervised learning strategy. So, mainly supervised learning is based out of classification techniques, whereas unsupervised is purely on a clustering technique. So, the training data like observations, measurements are accompanied by labels indicating the class of observation. So, which class it belongs to is already been predefined. So, thereby we understand the training data better. So, any new data that is to be classified is primarily based out of training set, whereas it is not the case with unsupervised learning, where the class labels of the training data is previously unknown. So, it can belong to any specific class and the class labels is unknown. Given a set of measurements and the observations as like your supervised learning, the aim is to find the existence of classes or clusters in the data. So, if there exists any predefined clusters or classes, this data will go directly reside, or if there is slight or outlier or overfitting of that particular data, it fits into actually the appropriate category that has been already existing. So, this the data that we are trying to give it as test value goes and resides on the previously existing clusters alone, whereas with classification it is not so. So, to evaluate on the classification methods, we have different evaluation strategies. One is to identify the accuracy, predictive accuracy, what method produces the maximum speed and scalability. Then we will, within the speed, we will try to understand the time to construct the model and time to use the model, and this model should be robust enough to understand or to handle the noise and missing values. Not only that, this classification methods should be scalable enough so that in case of disk resident databases, that should work more efficiently, or the efficiency should be prolonged as much as possible, and we may have to interpret on the data provided or the model provided by the user in terms of clear understanding, so that we gain the maximum information out of it. And finally, we look at the goodness of the rule, which are primarily focusing on the decision tree size and the compactness of classification rules. As a summary for this particular session, we have initially started with discussing on classification technique and data mining, where I have tried describing about classification and prediction. How is it different? Given a categorical list of attributes or any attribute being categorical, we might use classification techniques, whereas if it is tending to be a continual value, then we might use a prediction technique. Then I have started defining on the classification definition, where I used terms called training set, test set, which majorly concentrated on the group of or collection of records, attributes and class labels. So, the class labels are the ones which we may have to identify by use of these classification algorithms. And some of the applications of this classification include medical diagnosis system to identify whether they are malignant or other type of tumors exist, benign or malignant tumors if it exists, or could be of any other healthcare applications. Even this is more dominant towards banking transactions like credit card history, debit card and more of it, loan applications and so. In this particular session, we have talked more on the decision tree based induction algorithm. Although there are so many techniques that is existing with classification methods, but then we concentrated more on decision tree induction, wherein we took some examples of training sets, we created a model and we applied the model with a training value to identify how accurate these values are. So, the evaluation is dependent on accuracy, not only just as an accuracy, it is dependent on predictive accuracy and the way in which we understand the test set, that is interpretability, and how large we are looking at the data sets, how large is your training set, how large should be your testing set should also be looked after, which is scalability, and the way in which we write a rule, goodness of the rule is also a key point towards identifying decision tree induction. Thank you.